Hello, everyone, and welcome to today's Fortra webinar. Today's topic that will be covered is how to maximize your BI technology with a data warehouse. My name is Greg Schmidt. I'll be the moderator for today's webinar, and the main presenter for today will be Alan Jordan. Good morning, AJ. Can you give a little background on yourself before we get started here?
Good morning, Greg, and everybody. Yes, certainly. I'm Alan Jordan. I'm a senior software development manager here at Fortra. I've been with the company for 10 years. And prior to that, I was involved in data warehouse technology and implementation on the IBMi probably for the last 25 or 30 years. So a long history with the IBMi and data warehousing technologies.
Perfect. Thanks, AJ. And today, there's going to be a lot of content that's going to be covered here today in the webinar. So if we do happen to run over that 45-minute window today, and you do have to drop, you will receive a recording link after the webinar, so you can rewatch or send to anyone that you might want to watch the recording as well, that might not have been able to attend today's session. And feel free to enter any questions into the chat window, and we will address them towards the end of the webinar if time allows. And if we don't get to all the questions here today, if there is a lot of questions, we will follow up afterwards as well. Okay, AJ, I'm going to hand it over to you to kick us off here.
Okay, thanks, Greg. Okay, so here's our agenda. Firstly, I'm going to review some common challenges that organizations encounter when embarking on their business intelligence journey. We'll then see how a data warehouse addresses many of those challenges to maximize your BI technology. Next, we'll look at the philosophy and accepted best practices of data warehouse design, and then review some advanced concepts that you can use to supercharge your BI technology even further. And go to the next slide. And then, of course, as Greg said, we've reserved some time for Q&A at the end. It's not uncommon to find that your business intelligence effort is falling short of your expectations. There are quite a number of reasons for this, but the most common reason is simply that the application databases you're reporting from are extremely complex and difficult to work with. We will explore why that is on the next slide. Because of this complexity, the queries need to perform joins and transformations, and it's quite often beyond the skill set of many users. You may end up relying on just a few people to design queries and reports for everybody, rather than being the self-service environment that you might have been expecting. There are other frustrations too. It's common to find that reports don't agree with each other. Often there's a backlog of new requests that keeps growing. Some reports and requests never get fulfilled because they're too complex. Dashboards make a long time to load or to refresh, and I'm sure you've encountered other frustrations too. Let's understand why operational databases are difficult to work with. The primary cause is that they were designed for the application software to process transactions, not for humans to use for analysis. Think about a sales transaction. The database needs to be able to handle many different order stages: order entry, pricing, inventory check, picking, revisions, final invoicing, and shipping. The database design needs to be able to support these stages. There are several design considerations and best practices that result in a complex set of tables that are ideal for the software to use, but are very difficult for humans to use. It's common to find that the underlying data is quite different to what you see in the application displays, where it's been formatted and enhanced for display, applying logical rules that are hidden in the program code. Deal with legacy dates, missing or bad data, and many other shortcomings. And of course, there's always never any documentation available for the database. And you almost certainly have more than one operational database to deal with. It's not unusual to need to access data from 3 or 4 or more different applications. Each may be on a different technology platform: IBMi, Windows or Linux, Microsoft SQL Server, Oracle, and others. And each of these has its own set of challenges. And then it can get really difficult when you need to combine data from several different sources on the same report. When you can't create the report you need using your query and reporting tool, you look for solutions. Often, each challenge gets addressed in a different way. Users may download different sets of data to Excel and then merge and manipulate it on their desktop. Or you might develop a multi-step process, creating interim files before producing the final output. In other cases, you might have a program written to do the work. These ad hoc approaches can solve issues in the short term, but often become a problem over time, especially if they're not centrally managed. Who owns this process? Where is the source code? Documentation for them is probably non-existent, and error handling is unlikely to be included in these processes. I've shown this slide in front of a live audience many times over the years. And when I do, I always see a lot of head nodding as people recognize that this looks very much like their own ad hoc environments. I won't read the text and the callouts, but we'll pause for a moment here to give you a chance to read them. So how does a warehouse solve these issues? And since you've joined us today for today's webinar, I would expect that you're experiencing some of these issues and roadblocks that we've talked about. At a high level, we're going to explore these 4 key benefits of a data warehouse. And as we do that, we'll show some examples using SQL Data Warehouse. So we first need to do a quick introduction to the software. But what is SQL Data Warehouse? As the name suggests, it's primarily a tool for building data warehouses. There are 2 primary aspects to this. Firstly, it allows you to define and create the data warehouse tables and indexes and other structures. You don't need to be a DBA or to write the code to create and maintain the tables. The software does that for you. Secondly, it builds the extract, transform, and load processes that load data into the data warehouse. This is the most complex and challenging aspect of building the data warehouse. Without a tool like SQL Data Warehouse, it would require skilled developers who can code programs or procedures that are required to perform the ETL. The SQL Data Warehouse software simplifies this task for you, translating your business definitions into the code that does the work. One of its key features is the metadata repository. We'll talk more about this later. And with SQL Data Warehouse, you're building a powerful BI application. You'll work in a development environment to build and test definitions before deploying them to production. Literally everything you do is tracked and audited to ensure a full record of the data warehouse build process, as well as the daily ETL processes that load it. And finally, it's a native IBMi application, fully integrated with the database and the operating system. As a developer, building and maintaining the data warehouse, you would work with a modern user interface on your PC. It's very intuitive and easy to use, but it's also very powerful and productive. As an administrator, you have extensive configuration settings to control the behavior of the software. You can determine who is allowed to build or change definitions and ensure that the deployed data warehouse environment is only accessible to authorized users. As an end user who builds reports and analyzes data, you may not need to use this software at all. You'll continue to use the tools that you're familiar with, like SQL Data Access, to build your queries and reports. But now, instead of dealing with the ugly operational data, you'll point your tool at the SQL Data Warehouse tables. So, going back to our prior slide, let's start looking at how a data warehouse solves those BI challenges, starting with a single version of the truth. Remember that chaotic reporting environment slide? Various independently developed point solutions, each with its own design, different rules and calculations and complexity. When we introduce a data warehouse layer, we push all of that complexity to a controlled backend. No longer do we have standalone solutions. Everything flows through the data warehouse using the same technology with standardized business rules and validations in the ETL layer. Your front-end query and reporting tools, such as SQL Data Access, now point to the purpose-built, much simpler data warehouse that's a single version of the truth. To get to this single version of the truth, though, we need to solve the disparate data issue. We usually need to integrate data from several different data sources, sometimes needing to join them in the ETL process. And while it may be technically possible to directly join, say, DB2 data with Microsoft SQL Server data, it's not easy to do. Special tools are required, and in some cases, it's just not possible. A much simpler and more robust approach is to stage remote data locally using the same database used for the data warehouse, and in our case, that's DB2 for I. So let's look at how this is implemented in SQL Data Warehouse. It's a really easy process to do. First, you define a source group, and this is a description of how to connect to that remote data source, usually via one of the supplied connectors using predefined templates. Once connectivity is set up and verified, you simply identify the tables to be accessed. The software automatically accesses the remote database catalog, automatically defines and creates a DB2 staging table that is based on that remote table. And then it's a one-time step, and then it's a simple process to load data into the staging table as needed. So we've now got a local DB2 table that can easily be joined to any other table in an ETL process. This setup process is usually just a couple of minutes per table. It's a one-time setup task. We don't have time in this webinar to run through a demonstration. So instead, we've created a separate video that's available on our website that you can watch later and see this process in action. And we're going to send you the link to that video and some other videos after the webinar. Let's move on to the ETL process. The ETL is the acronym for extract, transform, and load. In the extract step, we access the data sources, performing any required joins and selecting the data to be loaded. The transform process is where the magic happens, transforming the often ugly raw data source into the format you want it to have. And that's usually composed of string operations on character data, calculations on numeric data, lookup and replace functions, date conversions, conditional logic, and much, much more. The last step is to load the transformed data into the target data warehouse table or tables, inserting new rows and updating existing rows. This ETL process can be very challenging if you attempt it without a tool. The SQL Data Warehouse tool has an incredibly powerful and easy to use ETL engine. You don't need to be a programmer or an SQL expert to use it. One very important but often overlooked aspect of ETL is the need to validate data during the process. Did a join fail? Did a critical field have a missing or an invalid value? Of course, if we apply validations, we also need to report on any errors and set aside the bad data. SQL Data Warehouse does this automatically. And finally, it's important to audit the entire process. When did it run? How long did it take? How many rows were loaded? How many rejects or errors occurred? How many inserts and updates occurred in the target tables? This all happens automatically in SQL Data Warehouse. An audit report is produced and the audit information is retained in the metadata indefinitely or until it's been purged. The ETL Designer is very visual. Here we see an overview that contains a lot of high-level information regarding an ETL process. In this case, we're loading a customer table. On the right-hand side, we can see left-hand side, we can see the data sources that are joined together. The processing is performed in the middle and loaded into the target table. You can drill into the details of that and see the table joins, and that's usually a drag and drop interface that is quick. That is a drag and drop interface. It's very quick and easy to use. And then there are the source to target column mappings. And you really cannot overstate the value of this visual mapping process. It's so fast to perform, and you can easily verify that you've mapped all the required columns correctly. We have a rule builder that for selecting the data to load and also validate, to perform validation rules. And one of the key attributes is that you can include descriptive metadata to describe the process of any rule. And this is a common theme throughout the software. There is a very powerful expression editor for building rules, allowing complex calculations. Many built-in functions are available, and usually find functions and much more. There are many other capabilities, some of which are listed here. Rather than a quick demo that leaves you hungry for more, like a tiny meal, we've got a very informative ETL video on the website. Again, you'll receive the link after this webinar. So let's move on. A data warehouse is designed specifically for reporting and analysis. So how do we do this design? I think you're starting with a blank canvas. You can design and build the tables any way you prefer. You need to make them look how you want them to look. And this will be very different to the ugly application tables that you're currently working with. Let's look at some of the best practices for design. First and foremost, you can and should choose user-friendly names. Many legacy applications on IBMi, especially those written in the 90s or early 2000s, use 6-character column names due to limitations that were implicit in the software and databases at the time. And here's a simple example of how transformative it can be to use meaningful names. These are the same table. In the operational database, you've got short 6-character names that are not user-friendly at all. The same table in the data warehouse, it's very obvious as to what each column or field is used for. And this simple example only has a few columns, but you're likely to be dealing with tables that have dozens, if not hundreds of columns. And many of those are totally irrelevant from an analytics perspective. We don't need to include every column, so we can simplify our data warehouse tables even further. Now we need to think about how we structure the tables. There have been many different books written about this with different approaches put forward over the years. Today, though, the most widely accepted and successful methodology is called dimensional modeling. Dimensional modeling includes several very useful concepts such as surrogate keys and slowly changing dimensions. So let's explore them. Tables in an operational database are transaction-oriented, as we mentioned previously. And that results in the information being spread across many different tables. But in a data warehouse, we don't need to process transactions at all. We need to analyze and report on the information contained in those transactions. One of the best ways to do this is to use what is called a subject-oriented design. Think about your business, in fact, any business. At a most basic level, your business sells products or services within a market, which is comprised of your customers, and you do that over time. Product, customer, and time are the 3 dimensions of virtually any business. And this is the basic concept of dimensional modeling. We could represent this basic 3-dimensional model as a cube. Think of it as a 3D spreadsheet. Each of these major dimensions have attributes. Products may be grouped into product line or brand. The time dimension has attributes such as date and month and year. customers have types and demographics and locations. You're not limited to these 3 dimensions. In practice, you might decide on other top-level dimensions, such as location or store, which may have attributes such as country or state or region. It's very common to have 5 or 6 dimensions in your model. The cube is just an easy way for us to visualize the concept. So this is the logical model. How do we implement it in a data warehouse? We use a structure called a star schema. A star schema is a set of database tables that has one central fact table that is joined to 1 or more dimension tables. In this example, we've got customer, time, branch, and product as our dimension tables, all linking back to transaction detail, which is sales orders or invoices. And one important design criteria of this is that we always use single key joins to join the tables together. This design makes it very easy to create an SQL statement that joins the tables and possibly aggregate data using any of the attribute values such as brand, customer type, year, and month. Surrogate keys are used in these dimension tables to replace the original key or keys of the entity. Surrogate keys are always numeric values, and they are simply assigned using the next available number. If you're familiar with identity or row ID concepts, these are essentially the same thing. So why do we use them? Well, there's several reasons. They can significantly simplify the joins between the tables. Remember, we said that in a star schema, we should always use single key joins. Well, what if the operational data requires 3 or 4 key fields to make that join? The single surrogate key value replaces those 3 or 4 original keys. Surrogate keys can also allow you to merge data from multiple tables which have duplicate key values. And another advantage is that they separate the logical joins of the data from the business values. Why is that useful? Well, for one, it allows for the structure of the tables in the operational database to significantly change without requiring a complete redesign of the data warehouse. In an extreme example, you might swap out your ERP application for a completely different one. It's going to have a very different table structure. If you did that, it would affect the ETL layer, but the use of the surrogate keys would insulate your data warehouse to a large degree from those table changes. And finally, surrogate keys are required to implement the concept of slowly changing dimensions, which is our next topic. Slowly changing dimensions provides a solution to a common reporting issue caused by changes to attributes of an entity over time, by allowing you to keep track of the prior values for an attribute. There have been several different approaches to tracking this over the time. If you read any books on dimensional modeling, they'll talk about 6 or more different types of slowly changing dimensions. One of them, known as type 2, is the most useful. That's the one we're going to focus on today. So what does all of this mean and how does it work in practice? So let's take this above example of a customer. And we're going to look at 2 different attributes of this customer, which are the customer group and the sales representative. And they're 2 important ways that we measure our customer sales performance. Over time, it's possible that they will change. In fact, it's likely that they might change. In this case, our customer grew from a small region or small store into a major retail store. As such, we recategorize them as a major retailer at some point. Later, a new sales rep was hired and assigned to this customer. The customer record was simply updated with these changes when it occurred. The operational database has no knowledge of the prior values, and this is normal. So if you run a sales report by customer group and sales representative with a year-on-year comparison, the report is going to be incorrect for prior years. It'll show, for example, that Rob McAdam made sales to this customer in 2002, before he was even hired. The solution is to generate a new customer record every time one of these key attributes changes. The new records are given the next available surrogate key value. Each record has an effective to date, which is for the current record is some unknown future date. So in this example, a surrogate key is a new identifier for the customer. We, of course, keep the original customer number, the original identifier, and then we need to include an effective to date column, and with the current record having some unknown date in the future, whenever it will next change. And then the last part of this is that we join the transactions that occurred at a point in time to the customer record or the entity record that was in effect at that date. Now you might be thinking that it appears complicated and challenging to implement this sort of thing, and without the right tooling you'd be correct, but it's not difficult with SQL Data Warehouse. Once more, we've got an in-depth video on the website that discusses dimensional modeling and slowly changing dimensions in a lot more detail than we've gone into here. And there's also a demonstration of how easy it is to implement this within SQL Data Warehouse. So how does moving on to the next step in how a data warehouse solves the issues, we're going to talk about documentation. Metadata is the roadmap to your data warehouse. You can think of it, metadata as documentation, and it can be broadly categorized into three different categories. First of all, technical metadata, and this describes the data warehouse tables and the indexes, the column names, the table names, data types and lengths, and other database related information. Then there's the business metadata, such things as the business rules that we use in the ETL processes, how a derived value such as net sales was calculated, for example. And this it essentially describes how to use the data warehouse, gives you context to the table names and the column names. And then there's operational metadata, and this includes things like the load history, the change history, and other important information that's collected and generated in the daily operation of the data warehouse. What we've found over the years is that metadata is essential to success. And with SQL Data Warehouse, the metadata is not just in text documents, Word documents, PDF files, etc. It is part of the application. There's a lot of structured metadata that is relevant, depends on the context of it, follows a specific pattern, etc. But the most useful part is what we call freeform text, and that can be entered at virtually any level. And it allows you to fully document everything that you define and build as you are developing it. There's some examples on the screen here. This is the main UI panel, and at the bottom there is a text panel which shows you the text for whatever you have focused on in the UI. And then when you go to individual property panels or rules panels such as this, you can see the relevant text for whatever it is that you're looking at. We don't have a specific video that covers metadata, but you'll see it in action in the demonstration videos the other videos that are on the website. Finally, it's a centrally controlled environment. Implementing SQL Data Warehouse gives you that very structured and managed BI environment. Nothing is stashed away on a user's PC or sitting forgotten in some random library somewhere. All the development activity is automatically logged against a project. Each change to a definition is archived in the version history, allowing you to revert back to an earlier version or compare versions. You'll typically maintain separate development and production environments, ensuring that you can develop and test new functionality before deploying it in production. And of course, there's procedures and capabilities to promote definitions from development to production. And whether that's on the same box or LPAR or a separate box, it's very easy to do. So as an administrator, you've got complete control over everything, including who's allowed to access an environment, the roles and responsibilities for the developers, the authorities on the objects that are generated, and much, much more. So this chart provides an overview of the SQL data warehouse architecture possibilities. And there are several capabilities of SQL data warehouse that we didn't even mention today. For example, change data capture using journal images is one way of capturing the data for loading into the data warehouse. Also, as well as building the data warehouse, you can use the same technology that is used to load from remote data sources to actually push data back to those external data sources. So we're not going to do a demonstration in the webinar today. Instead, as I've said before, we've got those videos that we've prepared on the website that will give you a much more detailed and informative demonstration than was possible in the time frame that we have for today's webinar. So, before actually, and I've got these. I was going to stop for questions here, but just in case we run out of time, Greg, I just want to go forward to the next slide, and then we'll come back to the questions. Yeah.
Perfect.
So, one of the, and this maybe somebody's got this question, but I just want to make sure we had time to answer it before we ran out of time. How and where do I start? So over the last 20 years or so, we've learned, sometimes the hard way, that there are good and bad approaches to building a data warehouse. The most important thing to realize is to recognize it's a journey. You don't need to completely build it before you deploy it and start gaining benefits from it. Work with your user community, the business leaders, the analysts, to identify the most important and pressing needs, the pain points and gaps that currently exist. Prioritize from that list. Often you can break things down into business areas such as sales, general ledger, inventory, and the like. And within each area, there will be subsets that you can further prioritize. For each stage, identify the most important reporting needs. What information is required? What groupings are needed for your analysis, your slicing and dicing, etc.? Where is the source data? What transformations and rules are needed? So you start building that from this design. You build the required data warehouse tables that are required for that area. And then you develop the ETL processes that would load those tables. And it's very important to keep the business community involved along the way. Include them in testing, get feedback, refine if necessary. And then when you're happy, the users have signed off onto it, deploy that piece into production. Then start on the next stage. Absolutely the wrong approach is to try to build it all at once. It will take years, or could take years, depending on the complexity. During that time, your business needs probably have changed. You'll deliver something that you've been working on for 2 years, and then the users will say, oh, wait a minute, what about this? Yeah, this has changed in the last 2 years. You didn't include that. You must. So it's so important to take this as a staged approach. You don't need to get it all done in one step. Start to deliver pieces at a time, getting buy-in and getting continued support from execs once you start recognizing the value that the data warehouse is bringing as you're developing it. Okay, let's go back to you, Greg, and questions.
Yeah, that's perfect. Thank you. Yeah, that's some great educational information, AJ. Yeah, and I just want to re-mention something that that AJ said as well is you will. So as a follow-up to the webinar, he's done some recordings for you to be able to go back and watch through more of a demonstration standpoint of some of these different topics. So you will be getting those as a follow-up to this as well. That'll be linked on our website. All right, let me see some questions here. We're in some good timing here still, so see some questions going here. Actually, here's one. Let's take. Give you one here, AJ. Here, how is the ETL triggered? This is a two-part question, actually. So, how is the ETL triggered first?
Okay. Oh, good question. So this we are a native IBMi application, which I think I said earlier. So we use commands. So there are quite a number of different commands that are associated with the ETL process. The most basic one is run this ETL job. You can, when you're developing, there's a button on the UI where you can say run it, and that in the background runs the command, and all the work is done on the IBMi platform. But of course, once you deploy this into production, you're going to need to create some sort of script or batch or CL program that will run these ETL steps one after the other. Often there are dependencies that this ETL must run and finish before the next one. So the bottom line is it's command driven. That means you can put individual commands on the scheduler. We do have a scripting concept in SQL Data Warehouse where you can just create a script that runs one thing after another. If you're a SQL Data Access user and you're familiar with their scripts, you can use scripts in SQL, and so, or you can write your own CL programs, or build other programs where one step in some other process is an ETL job. So very easy to integrate. So what was the second part of the question, Greg?
And and the second part of the question is, so it looks like they own some of the robot products, probably Robot Schedule. Can they schedule it with Robot?
Yeah, absolutely. I think really the first part answered that. Yes, it's a command. So of course you can schedule it in Robot. Yep.
Perfect. And let me go through here again. There's some good questions. We currently use SQL for our BI tool. Some reports need to run several times a day to keep the data up to date. How does the data warehouse support that?
Okay. The ETL process can be scheduled as often as you need it to run. So you, in many cases, overnight is the best approach. Excuse me, I've got a tickle in my throat here. But you could run this ETL every 30 minutes, every hour, depending on how long it takes. But it's probably a good time to also think about the different types of reporting that you are doing. If you need to run a report every hour, that means you're reporting on operational things that are happening in my business today. And that's really a different, I'm going to use a kettle of fish, to business intelligence. In BI and analytics, we're looking at the big picture. We're talking about this month's sales compared to last month's sales or something like that. We don't typically need to know what's going on in the business today. So we can think about two aspects of reporting that you today might be using SQL for. You're using it for operational reporting, and you're probably using it for those analytics and true business intelligence purposes too. And that's the beauty of SQL. It has it works in both of those environments. So one answer to that is you can continue to create those operational reports in SQL. You don't need to redevelop those for the data warehouse if you need to run them every hour. However, it might make sense to bring them into the data warehouse and then to work out a way, how do I run those reports on an hourly basis? So you'd put it on the job scheduler, run it every hour, and that scheduler could do, and in fact, it could be in a SQL script. Now the SQL script could trigger the ETL, it will wait for the ETL to finish, and then run the report. So lots of different ways to address this, and one further way is to use the change data capture process that we talked about. I briefly mentioned earlier. Change data capture through journal images allows real-time ETL. So I can join the CDC change data capture process to an ETL process and load the data warehouse tables in real time. I don't recommend that as a technique for everything that you do, because there are often codependencies where there are multiple records at different tables being updated at the same time, and I need to bring them together for validations and things in an ETL job, and that's not really possible when you're just processing journal images. But it has its uses. So if there's one particular report that doesn't need a lot of joins or validations, you could actually feed that data into the data warehouse real time, and then there's no ETL is happening real time, so there's no preload step that's necessary. Good question though, and lots of different ways to approach it.
Good. All right, we'll take a couple more here just for time purposes. The next one, does the data warehouse support incremental loads of summary data, or do I need to completely rebuild the summary file every day?
That's a good question. That's one of the strengths of SQL Data Warehouse. If you think about running an SQL job to do the update, an SQL, you're doing an insert or an update. It doesn't easily do both. And so the approach with SQL-based types scripts is that you would rebuild the summary every day. And I think that's maybe the origin of where that question is coming from. SQL Data Warehouse is different. It has the capability of processing row by row rather than as a result set, and it will automatically detect if this new row of data is if this already exists in the target table, in the data warehouse table. If so, it will do an update, and if it doesn't exist, it will do an insert. So yes, absolutely, you can incrementally load your summary tables. So let's say you've got sales data that you load every night from that day's sales. All of the new sales information will load into a detailed level table. So you might be building a table that's what we call the atomic level, which is new, is the transaction level. So that's always going to be new. But you might be creating a data mart table, which is a summary of sales by customer and product by month and year. And you will simply be adding in to the buckets for this customer, product, month and year record that's already in there. And while we're talking about updates, updates can get challenging too. Well, I've got multiple different rows in this table. Some of them, the numeric ones, I want to update and aggregate, like total sales for the month. And maybe in this table, you've also got a column called last invoice amount. Well, you don't want to update and aggregate that one. You want to replace that one. All of this is completely possible in the ETL process. So you can be updating some columns, replacing values in other columns, and there are also, you can say, well, only update this value on insert, never change it on an update, even if the source value changes. So everything is possible. Good question.
Perfect. And the last question here, can I load data from Salesforce?
Yes, you can. We don't provide the Salesforce connector in the software. It is available. There is a small additional upcharge for it. And that's because not all of our customers need it. But yes, there is a Salesforce connector, and we've got several customers successfully using that to both update. And in fact, we've got one of our customers in Europe that synchronizes uses the data warehouse to synchronize the operational data with Salesforce two ways. So sometimes data is entered through Salesforce and needs to come back into the data warehouse from Salesforce. And then there's other data that's created in the operational database, comes into the data warehouse and gets pushed to Salesforce. So yes, the answer is yes, both to and from Salesforce. Customers are doing that, yeah.
Perfect. Yeah, there is some other questions here, but for time purposes, we will get back to you on those other questions that are in there from that standpoint. So I just want to thank everyone for attending today's webinar, and we hope you've learned some very helpful and educational information about how to maximize your BI technology with the data warehouse. If you have any additional questions, feel free to reach out to us and our SQL Business Intelligence sales team here at Fortra. And we'd be happy to schedule a free consultation, a live one-on-one demonstration to address any of those questions one-on-one. And again, you will receive a recording link to the webinar so you can share with anyone in your organization that might not have been able to attend today's session, or if you'd like to rewatch any of those as well. And with that link, after that, you will receive some recording links to on the website that you can watch for more of a deeper demonstration that AJ put together as well. So thank everyone again for attending today's webinar, and I want to thank you, AJ, for the wonderful presentation and sharing your knowledge on this topic with us today.
You're most welcome, Greg. I'm always happy to do this, and yeah, it's been my pleasure.
Perfect. All right. Thanks, everyone, and have a wonderful rest of your day and the rest of your week. Thank you.